we studied about metals, nonmetals, and their physical properties. It is now time to understand the chemical properties of metals. In order to understand the chemical properties of metals, it is very important to understand the reactivity series. Reactivity series is an ordered series of metals along with the nonmetals like carbon and hydrogen inserted in between as reference. The metals are ordered according to their reactivity, that is, how easily they get involved in chemical reactions. Here you can see a phrase to remember the reactivity series. So here you have the reactivity series in the increasing order of their reactivity. The data in the reactivity series helps us to understand the reactivity of an element, their ability to interact with water, acids, and oxygen, etc. It also helps us understand if a metal will displace another metal in a single displacement reaction. To understand the reactivity series, it is important to understand as to what is electropositivity. Electropositivity is the ability to lose or donate electrons. So what does this mean? It just means that metals readily lose electrons and form cations. Electropositivity decreases as you go down the series. Decrease in electropositivity implies the decrease in electron donating ability too, which results in decreased reactivity. Higher ranking metals are more reactive than the lower ranking metals. Higher ranking metals hence are very difficult to extract from their ores or compounds. We shall look into the extraction of metals in more detail in the videos that are going to come up. With the help of the reactivity series, let us try to reason out how metals react with acids, salts, oxygen, water, etc. Let us start off with reaction of metals with oxygen, which is also known as combustion. Most of the metals readily react with atmospheric oxygen to form metal oxides. However, different metals have different reactivities towards oxygen. Unreactive metals such as gold and platinum do not readily form oxides when exposed to air. Metals burn in the presence of oxygen to produce metal oxides. Let us see what happens when we burn magnesium. As you can see, it burns with a bright white flame, and the reaction is here. The reaction goes like this. Magnesium reacts with oxygen to give 2MgO or magnesium oxide. When you dissolve the magnesium oxide in water and place red litmus in it, see what happens. It turned blue, right? So what does that mean? Yes, that means that magnesium oxide is basic in nature. Similarly, most metal oxides are basic in nature. Oxides formed by all these metals are basic in nature. We just learned that metal oxides are basic in nature, but are all metal oxides basic in nature? No. Some oxides of metals are amphoteric in nature. So what does amphoteric mean? Amphoteric substances are those substances that can act as both acids and base. When aluminium is burnt in air, it forms aluminium oxide. When we allow this aluminium oxide to react with acids and base, let's see what happens. Let's start with an acid. When you make aluminium oxide react with an acid like HCl, see what happens. Aluminium reacts with HCl to give you aluminium chloride, which is a salt, and water. So it is basically a neutralization reaction, right? So in here, aluminium acted like a base. Let's see what it does with a base, like NaOH. Aluminium oxide reacts with NaOH to give you sodium aluminate and water. So basically, it is also a neutralization reaction, correct? So in here, it is acting like an acid. So aluminum oxide is basically being like a base when treated with an acid and acting like an acid when treated with a base. That is why it is called as amphoteric. The other example is zinc oxide. Both zinc oxide and aluminum oxide are amphoteric in nature. Most metal oxides are insoluble in water, but some dissolve in water to form alkalis. Examples are potassium oxide and sodium oxide, which dissolve in water to give you alkalis. Let us see the examples. So, sodium oxide dissolves in water to give you sodium hydroxide, and potassium oxide dissolves in water to give us potassium hydroxide. Now it's time to see how metals react with water. Metals react with water to produce a metal oxide and hydrogen gas. Metal oxides that are soluble in water dissolve in it to further form metal hydroxide. But all metals are not equally reactive with water. This is basically because of their reactivity, right? So now let us see how different metals react with water. Let us see now how metals which are placed higher up in the series react with water. Let's start off with potassium. See how potassium reacts with water. And here's the reaction. Potassium reacts with water to give you potassium hydroxide, hydrogen, and a lot of heat energy. So if you look at all the three higher ranking metals like potassium, sodium, and lithium, you can see how violently they react with water. The hydrogen that they release during this process catches fire, as you can see here, because of the amount of heat it releases during the reaction. So basically, all these metals react violently with water. Now let us go down the series a little. Let's say calcium. Let us see how calcium reacts with water. As you can see, the reaction is not that violent, yet a lot of hydrogen gas is released, making the calcium float in water. And here's the reaction. Calcium reacts with water to give you calcium hydroxide and releases hydrogen gas. Metals like aluminium, zinc, and iron do not react with hot or cold water. It reacts with steam to form metal oxide and hydrogen. Again, the metal oxide that they form are amphoteric in nature. Let's see the reaction. Aluminium reacts with water to give you aluminium oxide and hydrogen gas. Look where these three stand in the reactivity series. Some metals like copper, silver, and gold, which are lower ranking metals, aren't very reactive with water. Now let us look at the reaction of metals with acid. Here you can see magnesium reacting with hydrochloric acid. Magnesium reacts with hydrochloric acid, giving you magnesium chloride and releasing hydrogen gas. So basically what magnesium is doing is it is displacing the hydrogen from the hydrochloric acid. All metals that are found in the reactivity series above hydrogen liberate hydrogen gas upon reacting with dilute hydrochloric acid or dilute sulfuric acid. So basically, metals which are more reactive than hydrogen will displace it in the acids as hydrogen gas. Now let us see how metals react with salt solutions. Metals that are placed higher on the reactivity series have the ability to displace metals that are placed lower from their salt solutions. So basically what it is telling you is that if you take iron and place it in copper sulfate solution, iron will be able to displace copper. But if you place iron in magnesium sulfate, it will not be able to displace magnesium from its salt because iron is less reactive than magnesium. Whereas iron being more reactive than copper, it can displace it from its salt solution. Let us look at it. So if I place iron in copper sulfate solution, it will displace the copper in it and form ferrous sulfate, putting copper out. Let us see the reaction. So iron here is displacing copper and forming iron sulfate. Now let us see how metal carbonates react with acids. Just like most metal oxides, metal carbonates are basic in nature too. So what will happen if a base and an acid reacts? Yes, a neutralization reaction occurs and salt and water are formed. Additionally, carbon dioxide is released here. When metal carbonates such as sodium carbonate and calcium carbonate interact with acids, they release carbon dioxide, which you can see here. Let us look at the example of sodium carbonate. Sodium carbonate, generally known as washing soda, reacts with an acid like HCl to give you NaCl or salt, carbon dioxide, and water. Metal hydrogen carbonates are basic in nature, as you can guess. Metal hydrogen carbonates are also termed as metal bicarbonates. Just like the metal oxides, they also produce salt, water, and carbon dioxide after reacting with acids. When metal carbonates are treated with carbon dioxide or metal carbonates of higher reactivity, they form metal hydrogen carbonates. Some examples of metal hydrogen carbonates are sodium bicarbonate and calcium bicarbonate. We would have done or witnessed this classic reaction, the reaction between sodium bicarbonate or baking soda with acetic acid or vinegar. Acetic acid or vinegar reacts with sodium bicarbonate to give you sodium acetate, water, and carbon dioxide. Till now, we studied about the chemical properties of metals. Now it's time to look at the chemical properties of nonmetals. Let us look at how nonmetals react with oxygen. So, reaction of oxygen means burning and basically it is combustion, right? Nonmetals react with oxygen to give you nonmetal oxides. So basically, when a nonmetal like carbon reacts with oxygen, we are going to get carbon dioxide. When sulfur reacts with oxygen, you're going to get sulfur dioxide, both of which are acidic in nature. Let us look at the types of oxides. So you have the metallic oxides and non-metallic oxides. So these oxides can be basic in nature, amphoteric in nature, acidic in nature, or neutral in nature. If you can see here, in metals, there can be two types. One is basic in nature. Higher up in the reactivity series, you can see metals forming basic oxides, whereas a little in the middle you can see zinc and aluminium, which form amphoteric oxides, that is basically which can be both acidic and basic in nature. In nonmetals, as you can see, some are acidic in nature like carbon dioxide and sulfur dioxide, and some are neutral in nature like water and carbon monoxide. Here you can have a look at different examples. Let's see what we have learned till now. We learned about reactivity series. We saw that electropositivity goes down as you go down the reactivity series, and then that the higher ranking metals are more electropositive and hence they donate electrons very easily and hence are very reactive when compared to the lower ranking metals. And we saw how it reacts with oxygen. Most metals react with oxygen to form metal oxides, some of which are basic in nature and some are amphoteric. And we also saw how it reacts with dilute acids. Any metals that are placed above hydrogen have the ability to displace the hydrogen in the acids and release it as hydrogen gas. Then when it comes to water, we saw that the reactivity obviously goes up as you go higher in the reactivity series, and again they form metal oxides, some of which are basic and some of them are amphoteric in nature. And the basic oxides are formed by reacting with water as such, but when it comes to certain metals like aluminium, zinc and iron, they interact with only steam, as the reactivity is lower than that of the higher ranking metals. And when it comes to salt solution, you do know that the metals which are higher up can displace the metals which have lower reactivity from their salt solution. We already saw the different aspects of reactivity series. It basically helps us to predict the way different metals and non-metals interact with oxygen, water, salts and acids. For example, potassium is more reactive than aluminium, which is more reactive than gold. Very reactive metals like potassium, sodium, and lithium displace hydrogen from water. Example, hydrochloric acid to give you magnesium chloride and releases hydrogen gas. Some metals like gold, silver, etc. are not very reactive, hence won't react with water. Metals displace lesser reactive metals from its salts. Example, ferrous displaces copper from copper sulfate solution, giving out ferrous sulfate, and copper is here. Potassium reacts with water to give you potassium hydroxide, releases hydrogen and lot of heat. Slightly reactive metals like aluminium, iron and zinc form metal oxides when exposed to steam. Example is here. Aluminium reacts with water to give you aluminium oxide, releasing hydrogen gas. Some metals displace hydrogen from acids, and these metals are placed above hydrogen in the reactivity series. For example, magnesium reacts with metals form metal oxides that can be basic or amphoteric in nature. Non-metal oxides are either acidic or neutral in nature, like you can see here. Metal carbonates reacts with acids to form salt, water and carbon dioxide. Example, sodium carbonate reacts with hydrochloric acid to give out sodium chloride, carbon dioxide and water. Metal bicarbonates reacts with acids to form salt, water and carbon dioxide. Example, sodium bicarbonate reacts with acetic acid to give out sodium acetate, carbon dioxide and water. In both these cases, we have carbon dioxide being released because of the carbonate group present in both bicarbonates and carbonates. Thank you kids. Hope you understood more about the chemical properties of metals in this video. If you have any doubts, please feel free to ask us.